Hi, welcome to another video on finding critical regions of a Poisson distribution. So let's take an example here. Lionel Messi is regarded as a super striker who plays for Statistics All-Stars. The mean number of goals she's scored over several years she has been with the club is 0.7 goals per game. She has now been transferred to Mechanics Ladies. The management at Mechanics Ladies wish to see if the rate at which she scores goals has now increased. Don't forget, this is now increased. We've got a direction, so it's a one-tail test. We call it a one-tail upper test. They monitor the number of goals that she scores in her first 10 games. Assuming a Poisson distribution, use a 5% level of significance to find a critical region for a one-tail test of the hypothesis that Lionel has increased her rate of scoring from 0.7 goals per game. And part B says to write down the actual level of significance of the test in parts A, or write down the actual significance level of the test in parts A. So let's go ahead and approach this question. So as always, we're going to start off by defining our random variable. So we're going to say let the random variable, so we say let the random variable x be the number of goals scored by Lionel in 10 games. So because we're talking about 10 games, we now need to find the rate. So the rate was now going to be n times p. So in our case, it's 10 times 0.7. So our lambda that we require is now 7. Okay. So we can now say that h0 lambda is 7 and h1 lambda is greater than 7 because they want an increase. So we say it's a one-tail upper test. And we know it's at 5%, so alpha level of significance is 0.05. So we say alpha is 0.05. So now, because we want an increase, we're going to say that, so don't forget it's the upper tail, so we just draw that here, the upper tail here, and that's going to be the upper tail of the test here. Shade that in here. So that's going to be 0.05, and this is where the critical value C2 is, and we could describe that as an inequality as the probability that x is greater than or equal to C2. So we want this to be strictly less than 0.05 in order to reject the null hypothesis. So like we did in previous videos, 1 minus the probability that x is less than or equal to C2 minus 1 is strictly, well, I'm going to write that a bit further down over here for clarity, or it will get a bit congested. 1 minus the probability that x is less than or equal to C2 minus 1 is strictly less than 0.05. 1 minus 0.05 is strictly less than the probability that x is less than or equal to C2 minus 1. So 0.95 is less than the probability that x is less than or equal to C2 minus 1. So in other words, we can say that the probability that x is less than or equal to C2 minus 1 is strictly greater than 0.95. So now we're going to get our Poisson tables. So from tables, and we're going to get our tables up now. We want lambda to be 7, and we need to find the first value strictly greater than 0.95. So we get a highlighter, scroll down, well, that's lower than 0.95, and this is going to be greater than 0.95. So we're going to write down those respective probabilities down. So from tables, we can say that the probability that x is less than or equal to 11 is 0.9467, and that the probability that x is less than or equal to 12 is 0.9730, and the value we want to choose is 0.9730. So we could say since 0.9730 is strictly greater than 0.95, therefore C2 minus 1 must be 12. So therefore C2 minus 1 is 12. So we can say therefore C2 is 12 plus 1. C2 is 13. Therefore, the critical region is x is greater than or equal to 13. So that's the required critical region. So now for part B, it says to calculate the actual significance level of the test. This is what's known as a type 1 error in chapter 8. Okay, a type 1 error is when you reject the hypothesis when it's actually true. So in our case, it's the probability that x is greater than 13. In our case, 1 minus the probability that x is less than or equal to 12. So in our case, 1 minus 0.9730. And that's going to be equal to 0.0270 is the actual significance level of the test. So now I'm going to go back to the question. The final part of the question states Leonora scores 11 goals. That's her observed value in her first 10 games for mechanics ladies. Comment on this observation in light of your critical region. So we can say part C here, the observed value x equals 11 does not lie in the critical region. So we can say we do not reject, make sure you've written down not carefully. We do not reject H0 at the 5% level of significance. The 5% significance level. We say test is not significant. And you must write all of this to get full marks in the exam. Test is not significant. And we must have our conclusion written down as well to get full marks in the exam. We say there is insufficient evidence. There is insufficient evidence to suggest that Leonora has not increased her goal scoring rates. Here's a question for you to try. You can pause the video when you're done. I will go through my work solution. Okay, welcome back. So the number of sales made by Hans, a telephone salesperson, averages 0.8 per day. Hans is given some extra training and his total sales over a period of 10 days is noted. Find the critical region for test at the 5% level of significance to determine whether the daily sales achieved by Hans have increased. So let's define our random variable. Let x be the random variable. So be the random variable. Be the random variable representing the total sales in a 10-day period. Okay, so we defined our random variable. Now we've got to find lambda. So lambda is n times p in our case. Lambda is going to be 10 times 0.8. So that's going to be... So we obtain that lambda is 8. So writing our model that x follows the Poisson distribution of 8, we can then say we want to find our critical region, and the question is asking to see if Hans's sales have increased, which is a one-tailed test. So let's set up our hypotheses now. So H0 is lambda equals 8. That's no change in lambda, basically. H1 is that there's an increase. And we say it's a one-tailed upper test. One-tailed upper test. Go and check the significance level. And that's going to be 5%. So alpha is 0.05. So you know what this diagram looks like. I'm just going to set up the equation straight away. So it's the probability that x is greater than or equal to C2, which is strictly less than 0.05. And we can then say from here, 1 minus the probability that x is less than or equal to C2 minus 1. Make the 2 a bit more clearer. Is strictly less than 0.05. So 1 minus 0.05 is strictly less than the probability that x is less than or equal to. So here we get 1 minus 0.05 is less than the probability that C2 minus 1. So 0.95 is strictly less than the probability that x is less than or equal to C2 minus 1. So in other words, the probability that x is less than the C2 minus 1 is strictly greater than 0.95. So now we're going to get to our tables. Let's get our tables now. I'm looking at lambda to be 8. So we get that here. So we can get rid of that. Go to the highlighter, go to 8. And we want to be the value strictly greater than 0.95. So that's lower than, that's greater than. So we've got our values that we need. Now we're going to write it. So here we're going to say that, and just making sure that lambda is definitely 8. Otherwise I would have chosen the wrong values. Lambda is definitely 8. That's fine. So it's going to be the probability that x is less than or equal to 12. So it's very similar to the example that we did initially. 0.9362, which is lower than the probability that x is less than or equal to 13. And that's going to give me 0.9658. Well, that's strictly greater than 0.95. So since 0.9658 is strictly greater than 0.95, we can then say that C2 minus 1 is 13, C2 is 14. So a critical region is x is greater than or equal to 14. So let's see what else the question asks. So, and that's it. So we found the critical region.